What is brown, hairy, and wears sunglasses? A coconut on vacation. All right, I made a slideshow for us. If it hopefully pops up, let's see. Share my screen, here it is. All right, friends, so this is our number rack, our lovely number rack. So we're gonna make combinations to 10 today. So from Monday, you saw combinations to 10, combinations to 20. So today we're gonna focus on combinations to 10. So imagining that I had my number rack here, I forgot to pack it in my bag before the quarantine hit. So we're gonna use the online number rack. So I already took some screenshots and pictures of the number rack and I hid half of the number rack. So these are just combinations to 10. So if we take a look at the white beads, the beads that are showing, how many beads are showing? 1, 2, 3, 4, 5. So we can't really use computational fluency because we can't see that there's red beads and white beads. So computational fluency is when you can add quickly. Say it, computational fluency. So computational fluency is being able to look at the screen and be like, oh, that's 5. But since we don't have anything to compare it to, we can't tell. So here, sometimes you can say, oh, well, this is computational fluency. If you were to add 3 cubes and then 2, if you were to add 2 plus 3, rather than just counting 1, 2, 3, 4, 5, one at a time, computational fluency is trying to see those combinations of numbers to get to the actual answer. So if we know this is 5, what is behind our blue shape? How many to 10? 5 plus what equals 10? Ooh, if you said 5, you were right. 5 plus 5 is 10. Let's count. 3 plus 2, 5. 3 plus 2, 5. So that is 10. All right, so it's our number rack flash game, just virtual. All right, take a look. How many counts? How many is there? 10. So how many is behind the shape? 0. All right, next up, try to solve it as quick as you can. Ready, set, go. Oh, look at this computational fluency. I know that since there's red beads next to the white beads, those white beads, there's gonna be 5 of them. So 5, 6, 7. So I'm gonna add 2 plus 5 because I already know 5 white beads, 2 red ones. So 7 plus what equals 10? Ooh, if you said 3, pat yourself on the back. Good job, friends, good job. All right, next up. Oh no, it's the same one. I think I forgot to delete the slide. How many is here? 5, 6, 7. Oh, 7 plus what equals 10? 3. Good job. Let's keep going. All right, how many? Yes, 2. But how many behind the shape? 2 plus what equals 10? Do you know it? Can you solve it? Let's double check. Oh, how many over here? 5, 6, 7, 8. So counting like that is a lot easier than counting each ball individually. 1, 2, 3, 4, 5, 6, 7, 8. Or I could say, oh, 5 plus, I can count on 5, 6, 7, 8. Oh, look how much faster I got to that answer. All right, ready, set. Oh, that was the last one. So we will play number flash game to 20 tomorrow though, okay? So I'm gonna stop sharing this screen, and what I want you guys to do is open up your composition notebook. So grab your composition notebook, open up to your next available page. I'm going to grab my pencil, my composition notebook as well, and lift this up so that way you can see. There we go. So you can see my page beneath me. So today is the 29th. I'm going to put math 4 dash, excuse me, it is not the 29th, 28th, Tuesday. So I'm going to share my screen. We're going to share our Pivo screen. Okay. Oh, there we go. The camera does not support this resolution. Choose a different resolution. I do not know what that means. Let's try sharing the computer one more time. Your camera does not support this resolution. Please choose another resolution. I do not know what that means, friends, and I hope you can see this. Not. Uh-oh. Let me see. Whoa. All right, friends. So open up your composition notebook. Let's see. There we go. All right, math 4-28. So we're gonna make some combinations to 10. What I'm gonna do, if you are on the left-hand side or the right-hand side, it does not matter, but we are going to fold that paper in half. Oh, that's not in half. So we're actually just gonna, since there's a red line, we're gonna find the middle and we are going to draw a line down the middle. So we're gonna do some number combinations to 10. So how we're gonna start off is we're gonna put number 1, we put it over here, number 1. So number 1, we're gonna start with our number combinations to 10 with the actual sum. So we're gonna put 10, we're gonna put equals, 10 equals. What we're gonna do is we're going to pick a number, either 10 or anything less than 10. So let's start with 10. 10, and over here on that left-hand column, we are going to add. So 10 equals 10 plus, and this is always going to be the number that we're going to solve for. 10 plus what equals 10? Well, if we have all 10 beads pushed over on our number rack, there are going to be 0 beads on the left-hand side. So 10 plus 0 equals 10. All right, so now we're going to come down here. Let's skip a line and then write 2. Let's try it again. Think of another number that is less than 10. Maybe you guys want to try 9. 9 plus something. All right, 9 plus what equals 10? So if we had 9 beads on the right-hand side, how many would be behind that blue square? 1, right? Let's add it. 9 plus 1 more is 10. Good job. So we're going to put a line. You guys will understand why we're putting lines. Let's go to number 3. Let's just continue to follow this pattern. So 10, 9, what comes after 9? Or what comes before 9? 8. 8 plus, and that's what we're finding. That box, that's what we're finding. 8 plus what equals 10? 2, yeah. Let's draw a line. Let's go on to number 4. We're gonna write 10. If you need to, pause the video at any time. Catch up if you need to. 10 equals, let's see, what's another number that's less than 10 that we can put here that we have not used yet? We've used 10, 9, 8. Maybe you guys wanna keep following this pattern. We're gonna put 7. 10 equals 7 plus, and remember, we are finding what is in this box. So we're setting up the problem to find what we need to put in the box. 7 plus what equals 10? If we had 7 beads pushed over, how many are going to be on that left-hand side? 3. Yeah. Oh, good job, guys. All right, continue. Let's go to 5. 10 equals, and what comes next? I think the birds in my backyard are having a heyday because I can hear them. But there's no more birdseed. They ate it all. Piggies. 10 equals, what numbers have we used already? 10, do you hear that? Do you hear the birds? Yeah. Would you like to say hi to Jonathan, everybody? Hello.
Hi.
All right, so 10 equals, let's use, we've used 10, we've used 9, we've used 8, we've used 7, and now we're gonna use 6. 6 plus something equals 10, right? 10 equals 6 plus something. So do you guys notice a pattern at all? I do. I see, look, these numbers, actually we'll start right here. These are all 10, 10, 10, 10, 10, 10. Equals, 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 equals. And then take a look at these numbers. 10, 9, 8, 7, 6. What's going to come next? 5. Yeah, they're decreasing. And then these are addition problems. And then look at the squares. What pattern do you see? 0, 1, 2, 3. So what is this going to be? 4. Yeah, I see some patterns. So that's the neat thing about math. Like our Fibonacci sequence, remember that shell that I showed you guys that basically grows and grows and grows and grows? So math is very symmetrical. With our combinations to 10, we did addition all the way up to 5. What we are going to do now is actually, let's take a look at our subtraction problems. So subtraction, we're going to set them up a little bit differently, and we're going to use the same exact numbers. So I'm going to show you using, I'm going to block this off with the whiteboard. All right, so 10 equals 10 plus 0. So same thing, we're going to continue number 1 just in this column. All right, so we know that this equation is going to equal 10. We need to, though, we're going to put a subtraction sign, minus sign, subtraction sign, whatever you want to call it. And we're going to have 2 numbers. We're going to have 2 numbers that we need to plug in. We've already used 10. You see how we already used 10? So now we're going to use these 2 numbers, 10 and 0. So think about it. Could we say 0 minus 10 equals 10? Could we have no candy bars and take 10 of them away? No, we would be in debt. We would owe candy bars. So we're going to have to put the larger number first. So we're going to put 10 minus 0 equals what? 10. Yeah, so if we had 10 candy bars to start out with and we took away none, we would still have 10 left, right? So let's do the same thing down below. We're going to do the same thing down below. All right, so 10 equals 9 plus 1. So we know over here we're going to write 10. And we know that we are going to use these 2 numbers because we have not used them on this side, in this column. So we're going to put the larger number here. What is the larger number? 9, yeah. And then I'm actually going to put a box right there. These boxes are going to be the same. So I'm going to place a 1. 9 minus 1 equals 10. Let's set up number 3 the same exact way. If you guys need to, if you need to pause the video to kind of comprehend what's going on, do it. Go ahead. So we're going to put equals 10. We're going to put our subtraction symbol, and then we're going to place a box right here. We are going to plug in the box from the left-hand column. What number is there? 2. And what number have we not used? 8. So let's go over this equation. 8 minus 2 equals what? 10. Yeah, if you guys need to solve it. I wish we had number racks, but we do not. But take your 10 fingers. Take 8 of them. 5, 6, 7, 8. Take away 2 of them. Oh, I'm doing this all completely wrong. Do you see? Is 8? Actually, let's go up to our second problem. Is 9 minus 1 10? No. So these are in the left-hand column, combinations to 10. In the right-hand column, these are going to be not combinations to 10, but we are subtracting within 10. So 9 minus 1. Let's go back to that equation. Let's take 9 fingers. 5 plus 4 is what? 9. Take away 1. So push down my pinky. How many do you have? 5, 6, 7, 8. Look at that. So take a look at this. We don't have, do you see any patterns here yet? We see 10, 9, 8. We see 0, 1, 2. Right here, we see 10, 8. Let's fill in this number and see if we begin to think of any combinations. 8 minus 2. What's 8 minus 2? If you need manipulatives, if you need to use your fingers, use them, friends, use them. Think about that number rack. Think about 8 beads on the right-hand side. Push 2 of them over to the left. How many would you have? 8, 7, 6. Remember, we're going to do dot. We talked about this in class. Those are the two dots representing 2. So 8, 7, 6. Let's add it. What's 6 plus 2? 6, 7, 8. It would be 8. So do you guys see any patterns here? I see that this is subtracting by 1, 10, 9, 8. I see this is adding by 1, 0, 1, 2. I see that this is subtracting by how many? 10, 8, 6. By 2. So if that theory is right, I'm going to continue to my next problem. 10, 9, 8. What comes before 8? 7. I'm going to write minus 0, 1, 2. What comes after 2? 3. All right, let's see if this pattern makes sense. 10. Subtract 2 is 8. Subtract 2 is 6. Subtract 2 is 4. Is this right? 7 minus 3 equals 4. It is. Let's double check it. 4 plus 3 equals what? 7. Yeah. So that's the cool thing about math. It's the cool thing about all the different combinations. So we're not using all of the same numbers from the left-hand column, but that's all right. So let's try this next one. 10 equals 6 plus 4. So we are actually going to use our number 6 over here. We're going to say 6 minus, and then which number is in the box? 4 equals, so we can count down by 2s. Maybe you want to solve this problem with patterns. Maybe you want to look and put 6 fingers up and take away 4 of them. How many do you have left? 2. Yeah, or you can say, I'm going to check that backwards. What's 4 plus 2? 4 plus 2. 4, 5, 6. Good job, guys. All right, so now what you guys are going to do, so you're going to practice a little bit more. If you need this, you can copy this down. But on the rest of the page, you can continue on this page. You can erase your lines so that way you have the rest of the page to work on our worksheets. So I'm going to stop sharing this, and I'm going to share my screen. So beneath this video is the worksheet. I've already posted it. I'm going to come over here so that way you guys can see, and I'm going to read questions for you. So here's our website. So I'm going to put the video right here. Underneath the video, I'm recording it right now, so it's not showing up. But here is our worksheet. So there's 2 pages, only about 7 problems. So I will read them for you. 6 penguins are on the ice. 4 penguins are in the water. How many penguins in all? So look at that piece of ice. 1, 2, 3, 4, 5, 6. Or you can use computational fluency and count by 2s. 2, 4, 6. So 6 are on the ice and 4 are in the water. How many altogether? So you don't need to write the whole answer. All you have to do is 1, and then you can, for number 1, you're going to write 6 plus 4 equals blank, and make sure you put penguins, because if I were reading this, I'd say 6 plus 4 equals the answer pens. Are we talking about cows? Are we talking about chickens? No, we're talking about penguins. So I would like you guys to work on this worksheet. Test your brain, see all the different combinations.